All right. Hello, Mr. Fatai. It's nice to meet you. And welcome. We'll begin momentarily. Hello, Abib. Good evening. Can you hear me? Hello, David. Please confirm that you can hear me. All right, that's great. That's awesome. Hello, Ibukun. Welcome. Okay, let's begin. Today we'll be talking about wires. Yesterday, last meeting we talked about panels. Before that, we talked about electronics. We went through some mathematics, and I believe you guys know um, fundamental things about our job, which is very important, by the way, because that's what differentiates you from someone who is just doing the job. Um, it makes your job more professional, and I think it's actually a fun thing to know, because as you do the job, you are going to realize some of these things we have been talking about, and I think you are going to love it. Today we'll be talking about wires. It's kind of like the one of the most underrated parts of our job. Hello, Abiodun, I see you. Hello, Jim or David. So wires are one of the most underrated parts of our job, but wires are actually one of the most important. There are five main parts of our job that are very, very important. The first is the panel, second is wire, third is controller, fourth is battery, and the fifth is the inverter. Hello, Emmy. Hello, Safe. Hello, David Jimo and Abiodun. I see all of you. Hello, Chinedu Emmanuel. Thank you for the other day. All right, so let's get into it. First, I'm going to talk about the materials in wire. By the way, I'm not going to be using the board today. Uh, what we're talking about doesn't really require me to use the board that much, but I'll advise you to pay utmost attention and take notes when you can. So first, we're going to talk about the wire, the materials in wiring. We have already discussed this in, I think we discussed this in the first meeting, and even the second, and even the Google Meet we had 2 days ago. The materials are very, very important because of something we call resistivity. We discussed the formula R equals PL over, which tells us that resistance is as resistivity increases, and resistivity is an intrinsic property of the metallic material used in creating the wire. So a copper wire is has a lower resistivity to compared to aluminium. That is why people prefer to use copper for your wiring. And in our line of job, actually, most of the time you're going to use for your installation is going to be copper, except nowadays that people who produce panels from the company already attach an aluminium wire to the junction box, just like Mr. Fatah explained 2 days ago. So the aluminium works fine too. It has its advantage. It doesn't rust, but most of the time we use copper because copper conducts more than aluminium, and we need as little resistance as we can get, because remember, power is rated with the formula P equals I square R, which means the higher the resistance, the more power wasted, and it's kind of a exponential effect. It's not just as if a little bit of resistance will give us a little bit power wasted. It's like two resistance give us 4 power wasted. Then 4 resistance is not going to exactly give us 8 power wasted, because of the formula is kind of it's not linear. Okay, let's continue. Yes, the materials used in creating the wires is very, very important. Um, the material dictates the resistivity. Now, next, let's talk about the types of wires we have. We have the single core and we have the flexible wire. When I say single core, there are those kind of wires that have just like a single metal in them, whereas the flexible are more flexible. Give me a minute. Let me see if I can find a sample for you guys. All right, I'm back. So we have the single core and the flex. This is an example of a single core wire. You must have seen it in house wiring. It's just like having a single metallic metal inside. This is a 2.5 mm cable. And then we have the flexible, we call it flex, which is this type of wiring. Okay. Look at how flexible it is compared to this one. This one is not exactly flexible, just bent. So those are the two main types of wires we have in our line of business. We have the single core, we have the flexible. All right. Okay, when do you use the single core? When do you use the single core and when do you use the flexible wiring? Well, it depends actually. How do I put this? There are two segments of wiring in our line of job. There are two places where you need wires: the DC part and the AC part. It's very important that you know that. There is the DC, direct current part, and there's the AC, alternating current part. AC is basically the same thing that NEPA supplies you with. But DC is the one that comes from the panel. The power that comes from the panel into the battery is direct current. That is, the wire we use in that part is different from the one we use in the alternate current part. The alternate current part of a solar system is the power that comes from the inverter to the house. There are two segments of wiring in a solar system: the DC part, which is the one that comes from the panel to the battery, and the AC part, which is the one that goes from the inverter to the house. That goes from the inverter to go and power the house. Remember, we'll get there, but let me just mention this. An inverter is a device that converts DC to AC. All right. So, what kind of wires do you use in the DC part, and what kind of wires do you use in the AC part? Well, the thing is, there is this general belief in our line of job by some people that, by the way, please don't hesitate to comment in the live chat if you have anything to say. If it's important enough, I'm going to respond. So there's this general misconception in our line of job that for the DC part, you have to use flexible cable. People say that a lot. Say you use flex cable. For example, if you were to use something like this to install, and then an engineer comes around and says, this thing is having problem. It's probably because the engineer used a single core cable for panel, and that engineer doesn't know what he's doing. But people tend to follow a trend in our line of business. When someone brings up something that seems legitimate enough, others will just follow it and they'll treat it as a proven theory without actually trying to prove it. But let me say this: you can use a single core cable in the DC part. In fact, at Imole Solar, we use it in our smaller packages. There is a but, however. You see, when you use the smaller cable, first of all, single core cables are usually in a small size like this. You can find the bigger sizes like 4 mm, 10 mm, 16 mm, but they won't really be worth it for you to use something like that. Okay, let me put it this way: in the DC part, we usually use flex cable, but let's say our 1000 watt 100 ah package. You can go and check our packages on our website imole.solar. Our 1000 watt 100 ah package it wouldn't be economical because apart from being a technical professional, you also need to be a business professional. You need to look at the economic side of things, especially for those of you that will go on to start your business. And for those of you that will be freelancing with us, you also need to consider that. I think I mentioned this on the first day. You guys are almost about more than 50 of you. Some of you, I think you're up to 80. If you pay attention enough and you get more than 70% at the end of the program, you will graduate. And then some of you who perform excellently well are going to be chosen to freelance for our company. And you don't necessarily work for us, you just freelance. Right? Whenever there's a job, we add you to our platform, we have a whole suite of platform. We give you all the resources you need. And then whenever there's a job, you can just go and do it for us and following our standards, by the way. Okay, so for a for a 1,000 watt 100 ah battery, you you wouldn't really want to use a flex cable because the flex cables are more expensive than the single core cable. For comparison, a single core cable is let's say 1 meter is 1,000 naira. By the way, when I say 1,000 naira, you need to consider the positive and the negative part. This is 500 naira. Then you consider the negative part, which will be another 500 naira. So 1,000 naira. Whereas the equivalent in flex will be close to around 1,500 naira or within that range anyway. And also, it won't be as durable or as strong as this one. So the reason why we sometimes choose to use this is economics, right? The cost. Mm, Cost is one reason why we choose to use this. There was I was saying that there was a but. You see, you shouldn't really use a single core cable in a system that deals with high current. High voltage, fine. But when it comes to high current, you shouldn't really use a single core cable. Um, for example, the 1,000 watt 100 ah package just have a maximum current in the DC part, maximum current of about 10 amps, which is well within the range of this guy. This guy can handle up to 18 to 20 amps. So this is well within the range. That's why we use it, right? And but if we're to be that package actually uses two panels. But if we're to be more than two panels, we won't want to use this because when you're approaching that 15 amps, no, a flex cable is the one that has like multiple tiny wires inside, right? This one just have a single thick wire, but flex will have multiple tiny wires inside, and it's also flexible, right? That is what a flex cable is. Yeah, I was trying to explain something. Yeah, so when you're approaching that 15 amps area, you realize that the wire will start getting hot. And when your wires get hot, it's a huge problem because remember, you are installing this on someone's roof where there's a lot of wood, and given the right condition, the heat can start a fire and then burn the person's house down. So we only use it in because of economics and in low current system. But by the way, you can actually use it in you should actually stick to flex cable, which is more professional. I'm just letting you know that single core cable is a good option. But let me tell you why you might also consider using single core cable. You see, flex cable have multiple points of failure. What I mean by multiple points of failure is that because there are multiple strands, tiny strands inside a flex cable, one or more of these strands may burn out because you see as the high current flows through the wire, and if all right, let me explain it this way. Each of those small strands of wire have a current limit. Let's say you are transmitting 10 amps, right? Let's say you're transmitting 10 amps, and each of those strands of wire can undo 1 amps. And let's say um, while um, tying the wires together, you tied like five. Let's say the flexible has 10 strands, each can handle 1 amps, and you're transmitting 10 amps. Let's say you mistakenly, like when you were cutting the wire or stripping the wire, you strip, you remove like four of it, that's remaining six, and then when you were tying it, you forgot to like you didn't notice one tiny one, that's remaining five. So you have five strands of wire connecting. And remember, there are limits, and those five strands of wire need to share the current equally. That's 10 divided by 5. That's 2 amps, which is more than what that wire can handle. And in such a situation, the wires are going to burn. Right? When it might not burn instantly, but when the customer keeps using it, and there's a day that the sun is going to come up sufficiently enough that the wire is going to burn. So that is why sometimes you might choose to use single core. You see, single cores don't really have that problem. Right? I told you something yesterday. I said, let me stop that beep, please. I'm coming. All right. I told you something yesterday that um, copper tends to corrode, unlike aluminum, right? So single core copper, actually, this single core cable has copper in it, takes time to corrode, right? It doesn't really corrode that much, and it takes time because it's one single layer. If it were tiny wires, it could easily corrode, but because it's one single thick wire, it takes time to corrode, right? So let me take a few steps back by saying we have two types of wire, the single core and the flex. You use the single core, we're talking, and there are two segments of a solar system that you use wires, the DC part and the AC part. Now, like I said, the DC part, you usually use a flex cable in the DC part. The flex cable. Yes, thank you very much, David Jima. Usually use um, usually use a flex cable in the DC part. However, you can also use a single core. One of the reasons why you might want to use a single core is because the single core is cheaper, right? And it's cheaper, and it doesn't corrode as easily as the flexible. When I say corrode, I'm talking about rust, right? In the case of iron, we call it rust, but in case of copper, I don't know what you call it, so I'll just say corrode. It doesn't corrode as easily as flex, so that's two reasons why we use them. But there are conditions for you to use them. You can't always choose to use them anytime. You can use them when you're dealing with high voltage, low current setup. And we haven't talked about controllers yet, but I mentioned a few things about MPPT controllers the last time we met. MPPT controllers work with high voltage, right? Let's say we have we have 10 pieces of 200-watt panel, and we want to use it to charge one battery, which is 12 volts. From what we discussed last time, we can just connect all those 10 panels in parallel. It will still give us the same 12 volts, and it will charge the battery. But if we were using an MPPT controller that can handle voltage or an hybrid inverter, we can choose to connect in series, which will give us 120 volts. That's 12 times 10, 120 volts, and maybe at just 5 amps, right? That's high voltage, low current. If we were to connect it in parallel to give us 12 volts at 50 amps, that's low voltage, high current. In such a situation, we can't use a single core. But because it's 120 volts for 5 amps, we can even use something as simple as this wire to connect them. You know why? Because this wire loves high voltage, low current, and it wouldn't really matter. It's the current that matters. The current is low, so we can use something like this. So I hope you have been able to understand how a single core cable might be applicable in the DC part of a solar system. Let's move on to the AC part of a solar system. The AC part is the one that comes from the inverter to the rest of the house. The AC part, we usually use a single core. Thank you, KB. We usually use a single core cable in the AC part of a solar system. When I say single core, this is what I mean. However, it is not always going to be one wire. You have probably seen those gray wires, that grayish wire that have two wires inside them, red and black. Those are also single core cable, right? It's just that they have combined the positive and the negative and bundled it up into one. But in this case, they didn't bundle it, right? So I hope you understand that. We rarely use the flex cable, which is this. We rarely use it in AC connection. It's very rare for us to use it in AC connection. But why? Why don't we use it in AC connection? Well, it's simple. The reason why we don't use it in AC connection is first, cost. These wires are more expensive than this. Except if you're going to buy the low grade one. The low grade ones are fine, you can use them. Another reason why we don't really use them in AC connection is because of sparks. They tend to spark more. You know, I told you multiple points of failures. If we have 20 strands inside one of the wires, and then one or five or six of the strands are not making contact, like they're making partial contact, that's when you'll be hearing sparks, right? You'll be hearing sparks, which is quite common, by the way. You see, out of the two types of wires, the flex is the most complicated one, right? You need to make sure you have the right number of strands, right? When you're peeling it off to expose the metallic part for to tape it to another wire, make sure you don't cut out most of the strands, because the number of strands you get actually matter. If there are 20 and you cut out 5, you have reduced the efficiency of the wire by 5%. And if the current is more than what it can handle, it will burn off. It will burn off and you can start a fire. So you should be really careful with the flexible cable. And if you don't have to use them, just use the single core. They're reliable, very reliable. But if you are dealing with high current, please don't use the single core cable. It is going to get hot, and that's the problem. Okay, all right. The next thing we'll be talking about is sizes, right? I gave you an assignment on day one to tell me the different sizes of wire, and most of you actually answered well. 1 mm, the 2.5 mm. This is the 2.5 mm, by the way. We have the 4 mm. This is the 6 mm. This is the 6 mm. The 4 mm is just a little bit smaller than this, but some people can't tell the difference. So some shops in Oja will actually sell the 4 mm for you for 6 mm. They will also sell the 2.5 mm for you for 4 mm, right? But as an engineer, you should be able to tell the difference. Where was I? There is the 10 mm, there is the 16 mm, right? Now, these sizes actually matter. It's one of the things you use to determine your quotation for your job, right? Now, why do they matter? It's because of that same formula we have been talking about since day one. R equals PL over A. The higher the area, cross-sectional area, the lower the resistance, right? So now these wires actually have current limits, right? Each of the sizes of this wire have current limits. What that means is that there is a limit to how much current they can handle. For example, I think the 2.5 mm is around 20 amps. The 4 mm is around 40 amps. The 6 mm is around 80 amps. I'm not sure. This is an assignment. Assignment, list all the sizes and the maximum currents they can handle. When you list them, divide them into single core and flex. So when you say 2.5 mm, when you say 2.5 mm, you send me 2.5 mm single core can handle so amps max. But if it's flex, it can handle so amps max. So that's your first assignment. Now, if I were to do an installation, how do I determine the currents that will be flowing through my wires for me to determine the size of the wire I'm going to be using? Well, this calculation is actually more important in the DC part of your system. It's also important in the AC, but AC you can actually make an educated guess. You can really guess what size of wire you should use. You can even do the same limit and just stick with 4 mm or 6 mm cable. By the way, we also have flex cable for the AC parts, but they are more of like thicker than regular flex cable, DC cable that we use for the DC side. Okay, I was trying to explain something just about now. Who can remind us where we are? Yes, the maximum current. How do you know the currents that will be flowing through the DC part, the current that will be flowing to the AC part. The DC part is easier to calculate. The AC part, you need to guess, right? The reason why it's easier is in the DC part, you need to look at who is actually supplying that current. That's the panel. By knowing the number of panels and the rating of the panel, you can determine how much current the panel batch, which will help you determine the size of your wire. But in the AC part, the current is determined by the load. The inverter can supply up to its rating. Like a 1.5 kV inverter can probably supply 1400 watts of energy. And the current it will supply will determine on how much things you plug in. You can't always tell how much the customer will plug in, but you can always ask them what is the heaviest thing they will be plugging in. That will help you determine the size. But let's not get ahead of ourselves. Let's talk about the DC part first. In the DC part, we can determine the current that will be through the DC part by knowing the number of panels, right? Panels have current rating. If you check behind them, the sticker behind them, you can see their maximum current, right? For example, a 200 watts probably have 7 amps or 10 amps, depending on the voltage it is designed to operate within. Yes, I gave one assignment the last Google Meet we had. Hope you guys have submitted that. So yes, so check the back of the panel. You know the maximum current it can supply. Now if we have a 200 watt panel, 200 watt panel supplying 5 amps at 12 volts, and we have 10 pieces of that panel or 5 pieces of that panel. If we connect them, the currents they will supply together depends on if we are connecting them in series or parallel. If we connect them in parallel, then they will supply 25 amps. That's 5 times 5. And then by that, you know that we definitely can't use this wire because this wire is designed to handle max 15 amps current. So 25 amps is going to make this guy very, very hot. So I should repeat the question. Well, the question is write the maximum current the wires can handle, each of the sizes of wire, and separates the single core from the flex. And then the second question, it wasn't really a question. I was just reminding you of the assignment I gave during the Google Meet. Okay, yes. So if you connect the 5 panels in parallel, you have 25 amps, which is more than our single core cable here can handle. Our single core cable here can handle around 15 amps max. But what if we connected them in series? Well, if you connect them in series, then it's 5 amps, which means this guy is fine. This guy is probably going to work fine for it. However, connecting them in series means you're going to get 60 volts, and controllers that will receive the panel power output also have a maximum voltage. We'll explain that when we get to the part on controller. I think that's probably the next lesson. All right, I hope you have been able to determine how you're going to size the wires you're going to use for the DC part. So for our 25 amps, we know we can definitely only use 2.5 mm. So we'll try 4 mm. 4 mm. 4 mm is fine. It can work for five panels. It can work, but well, it can work 25 amps. It can work. Just try to stay within the safe limit of say 70%. When you write out the maximum current each of these sizes of wire can handle, calculate of that. If current is less than 70%, use the wire. If it's not, use the next one. So let's talk about the AC part of wires. Well, in the AC part of wire, you need to determine the maximum or the heaviest thing the customer is going to be using. For example, in our 1000 watt 100 Ah package, we usually use a 3029 cable for the AC part, right? Because we know that the maximum it can handle is a laptop and a fan, which that is okay for. But then if the person is using an heavier laptop or an heavier fan, then it's going to cause a lot of issue and the wires will be getting hot. However, that issue really won't be on us because we already told the customer what to use with such a package. So you need to determine something else. In your installation, sometimes you might be required to kind of rewire the person's house, right? Take the changeover and create a new sequence, right? We'll get to that in probably towards the end of the video and the training. So, but just keep that in mind. So that's the way you size a wire. Now, there might be some situation whereby, remember the question, the problem we dealt with that I said it will be that we'll be needing to 25 amps of current, and this guy can only handle up to 15 amps. What if we only add this wire and we don't have another type of wire? Well, you can double this wire. Wires are like plus and minus if you connect them well. I can just double this wire to make it 4, right? If I double it and string them together, 2.5 times 2 will be 5 mm. So I've created like 5 mm cable like that, right? And I can do the same thing for my 4 mm cable. If I double it, I can get an 8 mm cable, which is what we did in Ibadan last week, right? So um, we'll talk about the maximum current. Let's talk about taping. That's the last. That's the last item on the agenda. I've mentioned this already, especially with flex cable or with any kind of cable. Make sure when you're tightening your wires together, make sure it is not loose. When I say not loose, don't just take it and just weave it together and no, or weave one on another. Don't do that. Do it the same way a lady's hair is plaited. Take two ends, weave one around the other, take the other one, weave it around it. So make sure you're doing it together and make sure it is tight when you're doing that. Right? That's the way to connect wire properly. Don't worry, in the practical session on the first week of resumption, we're going to look at tightening wire correctly. Also, when you tape your wires, tape them well. Right? Don't manage tape. When it comes to the DC part, don't manage tape. In the AC part, you can manage tape, but the DC part, don't manage tape. Right? Make sure you use like one roll of tape, right, on your on the roof there. Don't manage tape because over time, as the intensity of the sun or the brightness of the sun increases, the wires are going to get hot and it's going to burn through the tape. Exactly, that's what I meant, Emmanuel, pairing it together to make a single wire. So I think that's the end for today's session. Let me send you the attendance link. Hold on, please. So while I do that, please, any question or comment you have, send it to the live chat. I'm going to respond to them immediately. Yeah, if you have any questions, send it to the live chat, please. Send any question to the live chat. So I didn't really give an assignment on the Google Meet. It's just like a supplement to the other assignments. Alright, and that's fine, Emmanuel. The previous mode that involved having a board, right? That's fine. We'll go back to that, don't worry. Today is just trying something, trying to see how this will look. But don't worry, Emmanuel, we'll get back to that. We're actually trying to we're putting a lot of effort into these videos, right? So maybe a situation where I won't have to write on the board B again, but I'll just write on the tablet and you can just see it on the screen. Because I realize the board usually gives us some kind of glare, and maybe when the board is in focus, I won't be in focus, and when I'm in focus, the board is not going to be in focus. So that's what I'm trying to confirm with this. Okay, let's go back to YouTube. So I'm going to use my personal accounts to send the attendance link to the group now. Attendance link to the group now. All right, I've done that. So, all right, I've done that. So, okay, make sure you fill the attendance link on time. It's going to close in about 30 minutes or so. And we have 1 minute, 30 seconds remaining. If you have any question, send it to the group, please. Matthew, it is opening. Oh. You guys are always complaining that it's not opening. Check your network, please. Okay, yes. But you can't say the sent a question. What did you send? Let me see. How is cable logs used in wire? Okay, yes. Thank you very much, Oyeko. There is something called cable locks, not logs, lock, Lock, cable lock. Do I have one here? I don't think I have anyone close to me yet. But a cable lock is basically like a metallic object, like a round metal that people attach to the end of cables to then use it to like fix it on a battery or in other places, right? It's a way of doing something neatly. For people that don't want to be twisting the cable on the battery terminal, they just put that cable up, right? It's fine, it's great, but then there are some issues with it. Right? Let me put it that way. The issue is mainly around um, doing it right, because in the process of installing the cable lock, you have to hit it with an hammer to like maybe snap the iron in. But then in the process of doing that, you're going to weaken that place that you install the cable lock. Then, given a sufficient number of shakes, the cable lock is just going to cut away. And because you have weakened it, you're going to create, you're going to like reduce the area of that part. And remember, R equals PL over A. It will increase resistance in that area, increasing it, and eventually it's going to cut. That's the issue with cable locks. Cable locks are great, they make your work neater, but they're not reliable. They're not reliable. Maybe there are other types of cable lock that are reliable, but the ones I've seen in Nigeria so far, they're not very reliable. But that doesn't mean you should not use them. If you know how to install them properly, you can use them. So I think I've answered that. Okay, someone said the link is not working, but people have actually responded. Mujiu has responded. Let me try that again. The link is working now. Let me try that again, please. I've resent the link, but let me shorten the link.
Alright, I've done that.
So I've sent a shorter version of the link. So just to confirm, okay, YouTube is not displaying it as a link. Hmm. Okay, hold on. Okay. In that situation, I think they probably expect me to be the one to send the link. Hold on, let me resend it. Hold on, please. I'm going to close this just temporarily. Alright, I've resent it. Hope you guys have been able to use it now. Hope it's working fine now. Okay, we'll do it this way. Okay, I don't want to send it to the group. Alright, guys, I'm going to send, the link to the group, like the main group. I advise you to use it almost immediately, because you're going to have to remove it later, like in 5 minutes, like you guys suggested. So good night. You can leave the live stream now. Good night and take care.